Okay, in this video we're going to introduce derivatives, which are fundamental to learning calculus. So we're going to look at finding the derivative of a function. We're going to break this down into two videos just to not have one video go too long. But way back, several sections ago, we talked about the difference quotient for a function where we broke it down into three steps as evaluating the function at x plus h, and then subtracting the original function from that result, and then taking that difference and dividing every term by h. And the derivative is just another step after doing all this. It's finding the limit of your result as h approaches 0. So the bulk of the work in calculating the derivative is done in finding the difference quotient. So the derivative is the limit of the difference quotient as your value of h approaches 0. In other words, as you look at or another interpretation is as the average rate of change as your values of x get closer and closer together, and you calculate the slope of the line for values of x that get closer and closer together. Here you're calculating the slope of the line as, well, if h is 0, that means your x coordinates are getting closer and closer together. So the derivative, we mostly denote it with a prime symbol, so f prime of x is going to equal the limit as h approaches 0 of your difference quotient. And there's other notations for the derivative. Another very common one is dy dx. So in calculus, you'll see a lot of f prime or g prime of x or whatever. You also see a lot of dy over dx. We also have y prime as opposed to f prime of x. And then even another one, this one dates back to Isaac Newton, is taking your input variable, your independent variable, and putting a dot above it. Although we don't really use this notation too much today, but it does exist. All right, so example 1, find the derivative of each. We have f of x is 2x squared minus x plus 3. We're going to start by finding the difference quotient, and we're going to break that up into 3 steps like we did in the past. And then once we find the difference quotient, we'll look at the limit as h approaches 0 of that result. So first up, plugging in an x plus h into our function. That's a composition of functions. When we simplify this, x plus h squared is x squared plus 2hx plus h squared, and then distribute the negative to the x plus h in parentheses. And then we're going to distribute the 2 to each of these 3 terms, and we'll get 2x squared plus 4hx plus 2h squared minus x minus h plus 3. So quite a bit there. All right, our next step is to subtract the original function that we started with. Remember, when you subtract the function, each of these terms are going to become their opposites. So if we take this f of x plus h, and then we're going to subtract the function that we started with, distribute the negative, we get negative 2x squared plus x minus 3. And now, combining like terms, your 2x squared minus 2x squared is gone, your negative x plus x is gone, and then your 3 minus 3 is gone. So all that's left is 4hx minus h plus 2h squared. Our third step with the difference quotient was to take each of these terms and divide them by h. So when we do that, we get 4x minus 1 plus 2h. And this is the difference quotient. So now what we're going to do, one step further, is we're going to take this difference quotient and evaluate the limit as h approaches 0. Well, we can do this by direct evaluation, just plugging in a 0 for h, not going to cause any problems. So 4x minus 1 plus 2 times 0 gives us 4x minus 1, and that is the derivative of 2x squared minus x plus 3. So in terms of visually, if you take a point on the original function, let's say you take the point when x is 0, you get a y value of 3. So you got the point 0, 3 on that function. If you put a 0 in for x here, you'll get what's known as the slope of the tangent line to that point on the curve. In other words, the tangent line's only going to hit the graph one time, so at that one point. So derivative again, 4x minus 1. Part B, f of x is negative 3x squared. So once again, we're going to evaluate f of x plus h. Remember, your exponent comes first. So we get negative 3 times x squared plus 2hx plus h squared. Distribute the negative 3, and we get negative 3x squared minus 6hx minus 3h squared. Step 2, for the difference quotient, subtract the original function of negative 3x squared, which is going to become plus 3x squared, and then negative 3x squared plus 3x squared simplifies to negative 6hx minus 3h squared. Step 3 is, for the difference quotient, is to divide each of those terms by h, and we get negative 6x minus 3h. So now the new step is evaluate negative 6x minus 3h for a limit as h approaches 0. And again, we can just use direct evaluation. Here we get negative 6x minus 3 times 0 is negative 6x. So our derivative of negative 3x squared gives us negative 6x. Alright, that about does it for this video. We'll finish up things in this section in the next video. So I'll see you.